Hello dear students, this is your engineering mathematics 3 lecture. Today we are going to discuss few examples on Poisson distribution. In previous lecture also we have discussed Poisson distribution in few examples. Now here again we are going to discuss few examples on Poisson distribution. Poisson distribution, this topic is from 4th unit, probability and probability distribution. Okay, you see the example. In a Poisson distribution, if probability of R is equal to 1 is equal to twice probability of R is equal to 2. This equation is given. Then find probability of R is equal to 3. Okay. So using this equation, you first find the value of Z and then you can find the probability of R is equal to 3. So here we are going to use Poisson distribution. See, what is the formula for Poisson distribution? P of R is equal to e raised to minus Z into Z raised to R upon R factorial. This is the formula of Poisson distribution. Now here, this equation is given, P of R is equal to 1 is equal to twice P of R is equal to 2. Now when P of R is equal to 1, you put in this formula R is equal to 1. So the equation it reduces to it is equal to e raised to minus Z into Z raised to 1 because R is 1 upon 1 factorial. Again you find P of R is equal to 2 terms because here in this equation the term is there, P of R is equal to 2. So you put in the formula of Poisson distribution R is equal to 2. And so the formula it reduces to e raised to minus Z into Z square because R is 2. E raised to minus Z into Z square upon 2 factorial. This is the step. P of R is equal to 2 is e raised to minus Z into Z square upon 2 factorial. Okay. Now this equation, this relation is 2. P of R is equal to 1 is equal to 2 into P of R is equal to 2. It is given. Now you put the values of both the terms. P of R is equal to 1 is here. E raised to minus Z into Z upon 1 factorial is equal to twice P of R is equal to 2. See what is P of R is equal to 2. E raised to minus Z into Z square upon 2 factorial. Now you simplify this term. Here E raised to minus Z is present on both sides. So it will be get cancelled, e raised to minus Z, e raised to minus Z. Then 2 factorial upon 2 upon 2 factorial. It means it is equal to 1 because the value of 2 factorial is 2. 2 into 1, 2. This 2, numerator 2 and denominator 2 get cancelled. E raised to minus Z on both sides will be get cancelled. So in LHS the term is Z. In RHS the term is Z square. So Z is equal to Z square. This is true only when Z is equal to 1. The square of 1 is 1. The square of number is equal to that number itself. It is true for only Z is equal to 1. So the value of Z is 1. Now put in the formula. Now, sorry, what is our aim? Our aim is find probability of R is equal to 3. Now this is the formula of probability, Poisson distribution. P of R is equal to e raised to minus Z into Z raised to R upon R factorial. In this formula, you put R is equal to 3. R is equal to 3. R is equal to 3 and Z is equal to 1 because we have calculated the value of Z also, it is 1. So here in this Poisson distribution, put R is equal to 3 and Z is 1. So e raised to minus 1 because Z is 1, e raised to minus 1. Z is 1, so 1 raised to R, the value of R is 3, 1 raised to 3 upon R factorial. R is here 3, so upon 3 factorial. Now e raised to minus 1 into 1 cube. 1 cube means 1 upon 3 factorial. 3 factorial means 6. And e raised to minus 1, so we can write this term in denominator. So after simplification, the term is 1 upon 6e. 1 upon 6e. If we calculate the value using calculator, it is 0.0613. So this is the probability of when R is equal to 3. So this is the example in Poisson distribution. Next, again, there is one more example on Poisson distribution. The accidents per shift in a factory are given by the table. Here frequency distribution is given. Accidents per shift 0, 1, 2, 3, 4, 5. The values for accident per shift are given. Observation and the frequencies for these observations are given. It means that 0 accidents are there. 140 times in a shift. First shift 158 accidents. shift to 67 accidents, and so on. This frequency distribution is given. And you have to fit a Poisson distribution to the above table and calculate theoretical frequencies. This is your question. Fit a Poisson distribution to the above table and calculate theoretical frequencies. Now, how to calculate the theoretical frequency? Using Poisson distribution. Here we have to first fit a Poisson distribution. To fit a Poisson distribution, we want the value of mean, means the value of z. Here the frequency distribution is given. So using the formula that mean is equal to summation fx upon summation f, you can find the mean of the frequency distribution. We have discussed it in third unit statistics, how to find the mean when frequency distribution is given. The formula is summation fx upon summation f. Summation fx, f into x, you construct the table, and in that table you construct the column f into x. These are the values of x and f. You construct the column f into x, and then in last you do the total summation. That is will be the value of summation fx, and it is here 398 upon summation f. Summation f, addition of all the frequencies. It is 400. So if we calculate the value 398 upon 400, it is z is equal to 0.995. So this is the mean value of Poisson distribution here. Okay. Now we have to fit a Poisson distribution. So formula is here, P of r is equal to e raised to minus z into z raised to r upon r factorial. Okay. Now the value of z is fixed, it is 0.995. So put z is equal to 0.995 everywhere. Okay. Now here we want to find the probability distribution, Poisson distribution for every value of x. X is equal to 0, 1, 2, 3, 4, 5. So put r is equal to 0, 1, 2, 3, 4, 5, and you find out the probabilities at every value of x. Suppose r, this is P of r formula after putting the value of z. Now put r is equal to 0. R is equal to, suppose x, and the values of x are here 0, 1, 2, 3, 4, 5. So r is equal to 0. We put here in this formula r is equal to 0 and calculate the value. 0 factorial is 1, and 0.995 raised to 0 means 1. 3 raised to minus 0.995, its value is 0.3697. Then put p, sorry, r is equal to 1. Probability of r is equal to 1. In this formula, put r is equal to 1. Calculate the value. This is the probability. 0.36785. Then put r is equal to 2 in the same formula. Calculate the value. Put r is equal to 3, r is equal to 4, r is equal to 5 in the formula, and you calculate the value. So these are the probabilities at x is equal to 0, 1, 2, 3, 4, 5. Okay. Here the formula is written in terms of r, but for this example, we have given the observation in the form of x, that accidents per shift. The variable x is given. So that r is equal to x, and the values of x are 0, 1, 2, 3, 4, 5. So you find out this probability that x is equal to 0, 1, 2, 3, 4, 5. So this is a probability Poisson distribution fit to the given data. Now calculate the theoretical frequencies also. So the total frequency summation f, it is equal to 400. Summation f means addition of all the frequencies. It is 400. So you multiply every probability term by 400, means P of 0. Probability of r is equal to 0 into 400. R is here, r is equal to x here in this example. P of x is equal to 0 into 400. The probability of x is equal to 0 is here 0.3697. Multiply it by 400. So it is 148. Again, P of 1 into 400, P of 2 into 400. P of 3 into 400, P of 4 into 400, P of 5 into 400. And you calculate the values, you will get these frequencies. These are nothing but the theoretical frequencies for the given frequency distribution. The given frequencies are the exact frequencies, and these calculated frequencies are the theoretical frequencies from, we have calculated these theoretical frequencies from the probability distribution, Poisson distribution. Okay. So here the Poisson distribution Poisson probability distribution topic is over. I have covered all types of examples on Poisson distribution. Thank you. This session is over here. Thank you.